We used to believe that the most fundamental building block of matter was a particle known as an atom. Nevertheless, our understanding of the atom barely scratched the surface of particle physics. And soon after, a new theory called the Standard Model of Particle Physics was introduced to the world, which held and defined all the particles and their interactions with one another in the universe. However, one gaping flaw in this theory is that it fails to explain what gives particles their mass. Why do some fundamental particles have mass while others do not? Where does mass came from in the first place? This is very important to understand because without mass, everything in the universe will not exist, and this is where the Higgs field comes in. The Higgs field is the universal medium that covers empty space. Some particles flow through it freely while others interact with it, causing it to slow down and the particles to accumulate mass as a result.
Like electrons.
Imagine what would happen if there were no Higgs field and electrons were massless. Electrons would travel at the speed of light like photons do throughout the cosmos, and an electron that could not be bound to a proton wouldn't be able to form an atom, making life impossible. But if there is a Higgs field, electrons will move through this dense Higgs field and gain mass. Instead of whizzing around at the speed of light, the electrons will now interact with the Higgs field, gaining mass that requires effort to move, allowing electrons to settle down and allowing us to have chemistry and other forms of life. To expand the idea further, we have two individuals that went to the library. The Higgs field is represented by the books. The first person entered to get to the opposite side of the building and quickly passed through. She did not interact with her surrounding in the same way that some particles do not interact with the Higgs field, like photons, which are also called massless particles. However, the second person enjoys reading and visits the library to select books she wants to read. She will move slowly around the room, and because of her interactions with the field, she will grow into a huge particle. From this analogy, it's important to understand that until they enter the room, all particles are equal. Both the people in our analogy are massless. They gain mass as a result of their interaction with books or the field. The interactions with the field produce mass. This indicates that the particle's mass is affected by how it interacts with the field, much like different people will move through the library at different speeds based on their interests or aims. The Higgs field completes the last missing piece of the puzzle you and I are made of. They complete the Standard Model, but it doesn't mean that the discovery and unraveling of the mysteries of our universe will end there. This is just the beginning.